Balancing equations. Now, when we were balanced equations in 1211, we talked about balancing the atoms, etc. This is a little more involved, but we have to still mass balance. That means that we have to make sure the number and the type of atoms is equal on both the reactant side and the product side. But in redox reactions, to balance them, and we're going to use what's called the half reaction method. And there are a couple methods, but I'm going to tell you right now that this one is usually the easiest for 99% of the people. So this is the one we're going to do. For redox reactions, you can have acidic environments, in which case you may add H plus or H2O only. For a basic environment, you're going to have to add OH and H2O only. Now, here's the important part. You may not have to add either one, or you may only have to add one. For example, if it's a basic, we're going to work one where you don't add water, you just add OH minus, and that's fine. But the trick is if you're in an acidic environment, you better not add OH minus. If you're in a basic environment, you can add H plus. And I'll tell you right now, the acidic environments are way easier to balance than the basic ones. Now, that's common to what we did before, but now we have to keep up with our charges. In 1211, the equations we gave you charged balanced as you mass balanced. That's not true with redox reactions. In order to charge balance it, that means you're going to have the charge on the reactant side equal to the charge on the product side. In order to charge balance it, you're going to add electrons. And if it's a reduction, they go in on the reactant side. If it's an oxidation, they go on to the product side. Okay? When you add them together for both sides, they have to be balanced. So, for example, if you added 6 electrons on this side, but you only added 3 electrons on this side, this one's going to have to be multiplied by 2 so that we end up with 6 electrons so that they can cancel out. Okay? So, the number must be equal so that the electrons fall out of the equation. Okay? They're annoying and they're time consuming, but they're really not hard as we go. Excuse me. Some of them are easier than others. So here's one. And using the half reaction better method. Okay, so as I said, this is the half reaction method. It doesn't matter which species you start with. But, and as I said before, we put this up and we did work this one as a redox. We're not really worried about that right now. So the first thing is we're going to work with cerium. Now, if you'll notice, I'm not worrying about the states. Should you write them in? Yes. Do you have to? No, not until you get to the end. Okay. So we're going to look at it, and we have one cerium and one cerium, so it's mass balanced. Now we look at the charges. On the reactant side, we're looking at 4 plus. On the product side, we're looking at 3 plus. So therefore, we can add electrons. How many electrons do we add to what side? Well, we're going to add 1 electron to the reactant side, because 1 minus plus 4 plus equals 3 plus. So now we're mass balanced and we're charge balanced. Okay, so our second half reaction, and again, it doesn't matter which one you do first. You could have done the 10 first if you wanted. Again, we're mass balanced, and always mass balance before you charge balance. It'll get you in trouble if you don't. But we're going from 2 plus to 4 plus. So wait a minute. We can add electrons. How many are we going to add to what side? We're going to have to add 2 electrons to the product side. So that 4 plus plus 2 minus is equal to 2 plus, so we're charge balanced. Now, this is like adding two equations together, but in order to make sure that something cancels, our electrons must be equal. So we're going to multiply this one by 2 so that electrons are equal. Now, you can write it out or you can just rewrite it. And I'm going to leave the electrons in initially, but then I'm going to pull them out. So what we've got is 2 electrons here, plus 2 Ce4 plus 10 2 plus. Notice I try to keep my arrows lined up. I got 2 Ce3 pluses plus 10 4 plus 2 electrons. So if you look at it, again, it's like a math equation. If you have plus x on both sides, you can eliminate it. So our net equation doesn't have any electrons in it, the visible electrons, and you just rewrite it. So if we look at it, we now have 2 cerium, 110, 110. The total charge here is 8 plus 2 plus, which means it's 10 plus on this side. This is 6 plus, and this is 4 plus, so that means it's 10 plus on this side. So when you're done, not only are you going to check the mass balance, but you're going to check the charge balance. And the beauty is that if it mass balances and charge balances, you're correct. Okay? So you're done with the problem. Okay. That brings us to the next one. This one is done in an acidic solution. Now, how do you know? Well, you're going to be told. And when we have them on the test, I usually have you balance two. I have you balance one in acidic and one in basic. And today we're going to be working several of each one. And there are a bunch of extra ones posted, and there are more in your text. So we'll go from there. Okay, on this one, again, it doesn't matter which one we're going to do. I always like to start in the center with my arrows so that I know what I'm dealing with. Okay, there's my manganese. I'm going to do my iron 2 plus and my iron 3 plus. Now, on some of the acidic or basic, they'll put hydroxide in. Don't worry about where it's at because it may stay there and it may move. So the easiest thing is just to take it out and deal with the main species. Now, on this one, I wrote manganese first, but I'll have to do it first. And as a matter of fact, I'm going to do the iron first because it's going to be easier because look, it's already mass balanced. But I have to charge balance by putting one electron here. Because 3 plus plus 1 minus gives me 2 plus. So now mass balanced and charge balanced. Okay, so we're good there. So let's look at this one. We have manganese and we have manganese, so we have 1 and 1. We're good there. Okay, on the reactant side, we have 4 oxygens. How do we get 4 oxygens on the product side? Well, the only thing that we can add is water, and you have to have 4 of them in order to get 4 oxygens. So now I'm mass balanced with respect to manganese and oxygen. Now I have to account for the hydrogens. So I have 8 hydrogens, and it's an acidic environment, so I can add hydrogens in the form of H+. Okay, so just as a quick double check, 8, 8, 1, 1, 4, 4. We're good. Now I'm mass balanced. Now I have to charge balanced. So right now the total charge on this reactant side is plus 7. The total charge over here is 2 plus. So we have to make the 7 plus equal 2 plus. The only thing we have left that we can add are electrons. So we're going to add 5 electrons to the reactant side because 5 minus plus 7 plus gives me 2 plus. Okay, so now that means that when we go to combine the two reactions, the electrons must equal. So what you do is you look at the two numbers. We have 5 and 1. The smallest number that both of them will go into is 5. So this one's going to be multiplied by 1, and this one's going to be multiplied by 5. And again, I'll write the electrons this time, but I'm not going to do it after that. So I get 5 electrons plus 8 H pluses plus MnO4 minus, that takes care of my first half. Now I've got to have 5 iron 2 pluses going to manganese 2 plus 4 H2O. And again, it doesn't matter which order you do these in. 5 iron 3 pluses plus the 5 electrons. So again, if you look at it, the 5 electrons are going to cancel. So let's check our numbers here. So we have 8 plus 1 minus. And let me just erase got the pluses. 1 plus and 10 plus. So the total charge on this side is, no, that was a minus. Y'all let me get away with that. So I have 8 plus minus 1, that's 7 plus 10 is 17 plus. So on this side, I've got 2 plus 0 and 15 plus. So this one is at 17 plus. So because I left the electrons in there, I'm just going to rewrite it, which is why I eliminate the electrons as I do it. And as I'm writing this, you might want to double check the mass and the charge. We just did the charge balance. So double check the mass balance on it. It takes about, 15 seconds, and it tells you you're right. So we have 8 and 8 and 1 and 1 and 4 and 4 and 5 and 5. So we're good. This one is balanced. No problem. Remember, the electrons must cancel. So what that means is they must have the same number. So that would mean that if you had 2 here and 3 here, this one's going to be by 3 and this one's going to be by 2. If you had 4 and 2, this one's by 2 and this one's by 1. Okay, you just need to make sure they balance. All right, let's work the next one. So on this one, we're going to be dealing with chromium and carbon. Okay, this one may be a bear. Okay, Cr2O7, so this is dichromate, and again, you're not responsible for naming it. Goes to chromium. Then you have C2H5OH, goes to CO2. Now, if you look at it, there's water in there, and it's an acidic solution. I'm going to leave the water alone. I'm pretty sure it's going to go in the second one, but I'm not 100% sure, so I'm not going to do that. Again, it doesn't matter which order you do it in. In this particular case, this carbon one is going to kind of turn out to be a pill. Let me warn you on that one. So we're going to do the top one first. So notice I have 2 chromiums, so I need 2 chromiums. That's really easy to forget, and it'll mess you up. Won't say I didn't do it. Word to the wise. These are like math problems. Okay, let me rephrase that. They are math problems. So if you're getting one and you've got one number wrong, you're going to get real frustrated. Set that aside. Go take a break, eat a cookie, pet your dog, whatever. Then come back and start with brand new, fresh. Don't look at what you did, because you usually have a little error in there. It can be a state written wrong or a number not doubled, and it'll just fry your brain, trust me. So we've got 2 chromiums here. That leaves us with oxygen. It's an acidic solution, so we're going to have to get oxygen by adding water, and we need 7 oxygens. That's a lot. Okay, so total charge on the reactant side is 2 minus. It's 6 plus on the product side. So we're going to have to add how many electrons to what side. So we need to take the 6 plus down. So we're going to add, wait a minute, Yeah, that's 6 plus and 2 minus. Oh, wait a minute. We're not through balancing it. Ha! I knew there's something wrong. I didn't account for my hydrogens. I need 14 H pluses over here. Okay, now the numbers are going to make sense. So I have 14 H pluses plus a 2 minus. So my total charge is 12 plus over here. And I got 6 plus over here. So how many electrons do I add to what side? I'm going to add 6 electrons to the reactant side. So then this one is reduced. Okay? So now let's go do the bottom one. And look, I did add water so far on that side. So I have 2 carbons, so I'm going to double the carbons there. I've got 6 hydrogens on this side. And no hydrogen on this side, so I'm going to either add water or H2O. But wait a minute, I've got 4 oxygens. I got 4 oxygens over here. I only have 1. The only way to add oxygens is to add water. So if I have 4, I need to add 3 waters, because 3 oxygens plus 1 oxygen will give me 4 oxygens on that side. So now let's go back and look at our hydrogens. So we have 6 and 6. Okay, that's 12 hydrogens. Okay, so the total charge on the reactant side is 0, and the total charge on the product side is 12 plus. So we're going to have to add 12 electrons to the product side in order for the charges to balance. Now, this has 6 electrons, so I'm going to multiply it by 2 to get to 12, and this one already has 12, so I'm going to multiply it by 1. So what I've got is 28 H pluses plus 2 Cr2O7, 2 minuses, plus 3 waters, plus H2H5OH, yields 4 chromiums plus 14 waters plus 2 CO2s plus 12 H pluses. Okay, so if you'll notice, we have 8 pluses on the same side, and we have oxygens on the same, oxygens in the form of water on the same side. So we've got to cancel those out. So these 12 will cancel down to leave us 16 hydrogens here. 3 waters will cancel out here. So we're left with 11. So we have 16 H pluses plus 2 Cr2O7s plus C2H5OH yields 4 Cr3 plus 11 H2O plus 2 CO2s. All right, let's do a quick double check. I've got 16 hydrogens plus 6. 16 plus 6 is 22 hydrogens. I've got 22 hydrogens. I've got 4 chromiums. 4 chromiums. I've got 15 oxygens because I got 14 here and 1 here. That's 15. So here I have 11 plus 4 is 15 oxygens. I have 2 carbons. And so I've covered everything. So the total charge on this side is 16 plus 4 minus and 0. So that's 12 plus. This side it's 12 plus 0 and 0, so it's 12 plus. So I've mass balanced it, and I've charge balanced it, and I've checked it so that I know that this equation is correct. Okay? So we've done 3 acidics, so now let's do several basics, because the basics are usually a little more challenging. Sometimes they're not, sometimes they are. We'll walk through some of the pitfalls. So if we look at this one, we've got silver, and the silver is going to silver chloride. No, cyanide, that's cyanide, sorry. Okay, and you're like, wait, but the cyanide's not on the other side. Oh, wait, let's put it in because we have to have some. Now, this is forming a complex, so that means you can't take it apart. And on the other side, we have oxygen going to, well, something. It's a basic solution, so the only thing we're allowed to add is OH and H2O. Okay, so before we get started, notice that OH minus combines oxygen plus hydrogen. H2O, same thing, but you have 1 oxygen for every 2 hydrogens. These are 1 to 1. So you want to keep that in mind. The other thing is this one's negative and this one is neutral, charge-wise. So sometimes if you know the electrons have to go in one side, and you need to counteract the charge, you want to put the negative on the other side. There are a couple tricks to basic solutions if you pay attention. All right, so far I'm like, I don't have anything written for the oxygen, but we'll work on it. We really don't care. If we take a second, we know that this silver has got to have a 1 plus charge. All right, so if we look at it, silver is mass balanced, but the cyanide is not. So now we're all mass balanced. Total charge on the reactant side is 2 minus. Total charge on the product side is 1 minus, so we need to add 1 electron to the product side. So now it's 2 minus and 2 minus. Okay? All right, so that brings us to our oxygen. So we're going to need oxygen on the product side. So we can add either water or H2O. Now, if this one is the oxidized, that means this one is reduced, which means electrons are on the reactant side. So if the electrons are on the reactant side, odds are we're going to want the negative on this side. Okay? Now, a trick to this is if you put the hydroxide on this side, and that means you've got to put water on this side, since the water has 2 to 1 hydrogens to oxygens. If you match the oxygens, so if we put a 2 here, then that gives us 4 hydrogens to 4 oxygens. That means I can balance this by doing a 4. So at this point in time, I'm 4 and 4, I'm mass balanced and charge balanced. So that's a trick to match the oxygens so that they're even with the hydrogens on the other side. Okay? So having said that, we're mass balanced. We have a total charge of 4 minus on the product side. So that means I'm going to add 4 electrons on the reactant side. Okay? So when I go to balance this, this has to be multiplied by 4. This one has to be multiplied by 1. So what we're going to get is 8 cyanides plus 4 silvers plus 2 waters plus 1 oxygen produces 4 silver cyanides plus 4 hydroxides. So if you look at it real quickly, I have 8 carbons to 2 times 4 is 8 carbons. Why did I separate that? I have 8 cyanides. 4 times 2 is 8 cyanides, so those are all done. 4 silvers to 4 silvers. 4 hydrogens to 4 hydrogens. 2 plus 2, so 4 oxygens. So I'm mass balanced. My total charge on the reactant side is 8 minus. My total on the product side is 8 minus, so I am mass plus charge balanced. So this is my resulting equation. Okay, so that really wasn't that bad. So let's do another one. Okay. This is nitrogen, and this we're bouncing back to an acidic solution. Again, we know that. So this time we're adding H plus and water only as our options. And I'm going to tell you right now, it has nitrogen in it. Nitrogen tends to be really annoying. So pay attention when you have nitrogen, and especially when it's basic. Acidic is not quite as bad, but it can still be a bear. Okay, and copper goes to copper 2 plus. Now, again, it doesn't matter which ones we do first. So this copper is mass balanced, so I'm going to go ahead and put the 2 electrons in it. So now it's charge balanced, so I'm done with it. So now let's go up and look at our nitrogen. We have 1 nitrogen, 1 nitrogen. We're mass balanced. We have 3 oxygens and 2 oxygens. So we're going to need another oxygen. So we'll add water over here, which means we have to add 2 H pluses over here. So when we look at this one, we have a total charge of 1 plus on the reactant side and 0. So we're going to have to add 1 electron to this side. Okay, so that means we'll multiply this one by 2 and this one by 1 so that our electrons cancel. So we get 4H plus 2NO3 minus plus copper yields 2NO2 plus 2H2O plus copper 2 plus. And our electrons would have canceled. So we're going to double check our math. We don't have like H plus on both sides, so we're good there. We don't have water on both sides. So we have 4 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens. We have 4 and 2, that's 6 oxygens. We have 1 copper, so we're good there. Our total charge on this side is 2 plus because we have 4 plus 2 minus. Here we have 2 plus, so we are mass and charge balanced, so we are good on this one. Okay. The last one we're going to work is another basic. So we'll look at this one. Oh, look, it has nitrogen. And that's probably going to drive me insane, but okay. Nitrogen, NO3 minus goes to NH3. And aluminum goes to aluminum tetrahydroxide. Again, this is a complex, so you just put it in. And I don't want to touch the nitrogen yet. Let's do the aluminum because it's really easy to balance because guess what? All I have to do is add 4 hydroxides. Remember I told you that in a basic environment you're going to add OH minus and H2O. You don't have to add both. So in this particular case, we add 4 hydroxides and we're done. Now the only trick is that means it's 4 minus over here and 1 minus over here. So that means we need to add 3 electrons into this species. All right. Now, so that means that this one's oxidized, which means this one has to be reduced. And then that's going to be really important because that means that I'm going to add my electrons as my reactant. So that means that if my electrons are going in as my reactant, I'm probably going to put my negatives in the form of hydroxide in on the product side. Okay, so I have 1 nitrogen, 1 nitrogen. On this one, we're going to add hydroxides to this side and waters to this side. Now, some of these you're going to keep playing with and figure out what goes on. So I balanced the electrons, the oxygens earlier. So if we wanted to balance the hydrogens, and we want to make the hydrogens even. Why? Because an odd plus an odd gives you an even, right? But what number can you multiply by an even number to give you an odd? You can't. Not whole numbers, okay? So I have got to make my hydrogens even in order to get them to balance out here. So here I have 3 oxygens. That leaves me with 4 oxygens here. So that's not going to work. So I'm going to go back in and I'm going to remove my 3 and I'm going to move up. Let's try 5. So if I put a 5 here, I have 8 hydrogens, which I could get 8 hydrogens by doing a 4 there, but then that leaves me with 7 oxygens. That's not going to work. Okay? So this is what we call trial and error. This is why you work these with a pencil. Okay, what did I use to 5, right? Okay, let's move up to a 7. And remember, we have to keep an odd number so that we get an even number of hydrogens. So 7 plus 3 is 10, so that would be a 5 over here. So my hydrogens would cancel. I now have 8 oxygens. No, I have 7 over here. So the 7's not going to do it, but we're getting a lot closer than we were before. So let's move up to 9. So if I have 9 hydrogens here and 3 here, that's 12. So I'd multiply this by 6. So I have 6 hydrogens on both sides. Now I have 6 oxygens here and 3 oxygens here. So I have 9. So yay! I am now mass balanced. Okay. So let's look at our charges. We have 1 minus on this side. We have 9 minus on this side. So we have to add 8 electrons, wow, on this side. Now, should this worry you? No. We'll be working problems later where we're going to be transferring 20, maybe 30, even 40 electrons. So don't sweat the small stuff. Come out with whatever the answer you have. So now when I look at it, I got 8 electrons on this side and 3 electrons on this side. What's the smallest number that 3 and 8 will go into? 24. So that means we're going to multiply this one by 3 and this one by 8. Okay, so here we go. So we're going to have 18. Yeah, 3 times 6 is 18, sorry. Waters plus 3 NO3 minuses plus 8 times 4 is 32 OHs plus 8 aluminums. Yields 3 ammonias plus 27 OH minuses plus 8 aluminum tetroxide, tetrahydroxides. Okay, so now when we look at this, we've got water on one side, but we've got hydroxides on both sides. So I've got more hydroxides on the reactant side, so let's cancel it out. So I end up with 5 hydroxides over here. So I'm going to rewrite it, 8H2O plus 3NO3 minus plus 5 OH minuses plus 8 aluminums yields 3 NH3s plus 8 aluminum hydroxides. All right, let's really quick check our math. We have 36 plus 5. What's 36 plus 5? 40. 36 plus 5. All right, the way I'm doing, I'm going to make my calculator. So I have 41 hydrogens. I have 18 plus 9, which is 27 plus 5. I have 32 oxygens. I have 3 nitrogens. And I have 8 aluminums. I think I caught everything. Over here, I have 3 nitrogens. I have 3 nitrogens. I have 9 hydrogens here, and 4 times 8 is 32. 41 hydrogens. Okay, I have 8 aluminums and 32 oxygens. So if I look I'm good, so I'm matched on that side. I have a total charge on this side of 0 plus 3 minus plus 5 minus plus 0. So that would be 8 minus on this side. Over here I have 0 plus 8 minus, which is 8 minus. So I am mass and charge balance. So therefore I have balanced this redox reaction. Now remember, the basic ones are the tricky ones because of the OHs and the H2Os both having both species in them. And you will be asked to balance one acidic and one basic on the test, or one basic. Because if you can balance the basics, you can easily balance the acidics. Okay, we'll move on to one more second segment in the lectures that goes on the test.